Welcome back to the next clip. Now we will take a look how we can mesh and extend our simulated area. So let's dive in here in the guided ocean layer fluid extended, and perhaps it will start to simulate because at the moment we are still importing the simulation. So let's drop down a file node here and we will read back in our cached flip. So it's in 0308 end, or perhaps in another folder depending on your settings when you cached it out. So here it's called compressed cache, and then we will read in the sequence. Okay. So now let's just select all these lines here and connect them to our file node, because we don't want to read the simulation, we want to read our cached fluid. So let it calculate a moment, because now it's calculating the actual fluid surface. Okay, we can get rid of this node here. Let's clean it up a bit, move this node up. Okay, so now let's take a closer look to all the nodes which are in here. Basically, this here is the part which will be rendered in the end. So here happens the meshing of the fluid and also the extension of our ocean. But these nodes here are also really important, because here is the particle fluid mask node. And this will take care of writing out the mask and the spectrums for our rendering, the displacement. So that here in the simulated area will be less displacement, and then it will be faded or blended in the area where there's no simulated data. Okay, so let's take a look. Here we have a surface preview node. This is really useful to get a quick preview of all the settings. So let's jump to frame 5 here, for example, because on frame 1 it's not possible to mesh anything. Perhaps you notice that this node here calculates really fast. Instead, the meshing for the final surface takes much longer. Let's just set the display flag here to take a look, and you can already see that it takes much longer because it's doing more operations to get a nice surface. But for preview purposes here is fine, and most of the settings are linked to the final particle fluid surface node here. And basically the speed difference is because of the output settings here. Here you can take a look at your simulated particles, or you can choose compressed fluid surface, which is just an approximation of the final mesh, but it calculates really fast. But as you can see, you don't have any attributes here, so for the final mesh we need to use the surface polygons or polygon soup. But for now it's fine, just to get a preview. Let's visualize nothing here at the moment to get a better view of our mesh. And the filtering is also deactivated because of this compressed fluid surface setting here. Also more interesting in our final meshing process, but what we can take care of here on this surface preview node is the extension of our simulated area. So let's take a look at the regions tab here. Here we have several settings to extend the ocean. All this stuff is happening down here, and at the moment the shape of our mask, or the flattening, how it's called here, is a circle. Basically we want to do a rectangle here, so that fits better to our boat. And at the moment you can see that it's really cut off here. That won't look nice in the rendering, so we need a smooth transition. Let's tweak the parameters here a bit. So the max height let's set to 4 because we have really big waves, and the flatten distance we will set to 5. So now you can see that it's fading in more from the bounding box here to the center. If you increase it, it would fade in even more, but that's not what we want, because we still want to keep our fluid simulation in the middle. 5 is a good value here, I think. Now let's activate the pad bounce. With this option activated, you have the possibility to extrude the edge polygons to get the grid for the displacement. Okay, so let's see here. We have planar or along each axis. In this case we will use the along each axis option. And now you have more settings down here. As we are looking for an infinite ocean in the distance, let's put 1500 here. And basically now we have our grid for the displaced ocean. The extrude divisions are fine here, but let's just display the flat wire shaded for a moment. And now you see that we have really big faces here. And also behind our camera we have a huge ocean plane. So let's use another useful feature here, which is the camera option, so we can generate this grid and also the meshing of our fluid based on the camera perspective to save some geometry. So let's tick on here camera, and let's look through our camera, and now for sure we need to pick our render cam here. Okay, and now you see nothing because the Z far distance is set to 2, so it will only mesh and display this grid between 1 and 2 meters. That's not what we want, so let's put here 0.1 and here 2000. Now you can see that we get back our mesh fluid and also the grid in the distance, but the grid is cut off here, and that's because of the low extrude divisions. So let's increase this here to 350, so we have enough divisions to do a proper cut here around the frustrum. Also, what we're going to increase here is our window scale for the camera, again to keep all what's in the camera view. Okay, so now you can see that's looking like this, much better. Back to our render cam view, and also if we jump to another frame, 71 for example, you will see that it's just meshing the necessary area and also generating this grid in the necessary area. For the final meshing quality, we also want to rebuild the SDF to adaptive. Let's change it here because we're going to link these parameters now to our particle fluid surface node. Okay, now let's link the parameters we just changed, because down here you can see they are not linked. So to make the linking easier, let's bring up just with the right click here parameters and channels and the parameters view. So we have all the parameters here and we can easily link them. You can see some of the parameters here are already linked, but we are going to link the rest as well. So just do right click here, copy parameter, paste relative reference, and let's do this for all the parameters here. Just really quick, copy parameter, okay. And also for the camera settings. So if you change anything later on the surface preview, it will also be changed here. Okay, that's looking good. So now all the important parameters are linked here. Let's close this parameters view and take a quick look to the final mesh. You can already see it calculates a bit longer. So here it is. Now we're going to tweak the surfacing and the filtering of our final output mesh here a bit. As you can see, the particle separation is already linked to our simulation. So if you changed the particle separation later on for testing or so, make sure you have the setting here which you used when you was sending out the cache. And down here you can see it's already set to surface polygon soup, which is fine, so it will have a velocity and it's a real mesh. And now let's take a look at these settings here. With the voxel scale, basically you can define the resolution of our mesh. If you lower it, you will see it calculates longer, but eventually you get more detail out of it. But the particle separation also acts as a multiplier for the voxel scale. So basically with a standard setting of 7.5 you are fine. The influence scale also acts as a multiplier for the particle separation. So if you increase it, you will get a bit more detail perhaps and a smoother mesh, but the calculation time also increases. So let's stay with the 3 here. The droplet scale is interesting because it not only influences the droplets, it influences the whole mesh. So let's put a 0.5 here, and it acts like a p-scale multiplier on your particles, so you don't get more resolution, but the p-scale of the individual particle is a bit smaller, so you get sharper detail perhaps, something like a peak function. So let's stay with 0.5 here. Also let's lower the erosion scale a bit here to eliminate seams around our simulated area. And the last step we will take a look at is the filtering. Here you have several options to tweak the look and enhance it of your simulated particles. Let's tick on the dilate function here, and you see that the erode now is also ticked on. This will improve the look of our surface. In some cases the smooth or the final smooth option are also useful to eliminate artifacts in your meshing. But in our case, the mesh already looks pretty nice, as you can see here, so we won't use it to save some calculation time. Okay, that's it so far for the meshing settings. Let's take a look through our render cam. And now we will take a more detailed look here to the particle fluid masks. You can already see this goes down here, and then we have an ocean evaluate, which gives us a preview in the viewport of the simulated area and the displacement for the grid. So that looks a bit strange at the moment because we don't have enough resolution here on our grid to see the proper displacement. But what we can see is that in this area here we get somehow too much displacement. So let's take a look at these two particle fluid masks here. The first mask here is just taking care that the spectrum gets added outside of our simulated area for the displacement. That's why you can see this box here. So it masks the simulation area so that the displacement just happens outside. So this mask here is fine, and now let's take a look at the right one here, which is a high frequency mask. Basically this mask is filtering out based on a velocity and a resolution of your spectrum, just the high frequency detail. That's why here is ticked on filter below resolution 6. So the use of this mask is that it will take care of adding the small detail of your displacement also to the simulated area, but not the low frequency details. So we just get the small and fine detail of our waves on top of our simulation, which is really useful. So make sure that here, but just here on the high frequency mask, the remove non-spectral waves is ticked on. So what's a non-spectral waves? Basically, these non-spectral waves are the waves which are generated manually, so not with the ocean spectrum. And that's why this mask node cannot detect on this non-spectral waves which waves are below resolution 6, and that's why it's just adding everything on top. So make sure you have it ticked on the remove non-spectral waves. In our case, the non-spectral waves are coming here from the guided ocean layer initial, and here we are using this ocean wave SOP, and this is generating these non-spectral waves without a spectrum. Okay, so let's jump back here to our extended fluid, and now it already looks much better. And basically we could cache out here our mask for the rendering process, but as you remember, we tweaked our spectrum here, the look of our waves, just for the simulated area. So now if this settings gets extended in the depths, so until the horizon, it might not look realistic and repeat the pattern. So in the next clip we're going to tweak our spectrums, but just for the rendering. It's a bit tricky because we need to make sure that in the simulated area we keep the same look, so our simulation is matching with the displacement, but the advantage is that we now have the freedom to tweak the look in the background of our boat like we want. The other option would be to tweak before we simulate everything, also the ocean spectrums for the background, so we have one big spectrum which is working in all areas. But I think with this workflow we are more flexible also to react to changes. So perhaps you have a nice simulation, but the background is not working good. Perhaps your supervisor tells you we need to change the background. Then you're way more flexible because you can change the look of your ocean in the background as you want or as it's requested. So in the next clip we will take a look how to do this, and we will set up a few more ocean spectrums just for rendering. See you there.